to say. So yes, in this case, they say a sodium hydroxide solution is prepared by dissolving 4 grams of sodium hydroxide in water to make a 500 cubic centimeters solution. Now they say calculate the concentration of the sodium hydroxide solution. Well, that's perfectly fine. We can easily do that. But now they say during a titration, 12.5 centimeter cubed of sodium hydroxide solution neutralizes 25 cubic centimeters of a sulfuric acid solution according to the following balanced chemical equation. So we have 2 moles of sodium hydroxide reacting with 1 mole of sulfuric acid in order to produce 1 mole of sodium sulfate and 1 mole of water. And now they're asking us to find the pH, but listen, it's the pH of what? It's the pH of the sulfuric acid solution. Just this H2SO4. Not the pH of the final solution, maybe at the end point or the equivalence point. So it's 2 different things. It's different to the one that we are going to do next. So how does it differ actually? Well, I think it's much better if we do that one, and then I can make a contrast between finding the pH in this case as well as in the next case. So then how can we find this pH of the sulfuric acid? Only the sulfuric acid. So what we need here is just to calculate the concentration of the sulfuric acid solution. That is all. And now that we know the concentration of sulfuric acid, then we know that 2 moles of hydronium ions will actually be produced, which means the concentration of the hydronium ions will be twice as much that of the acid. How do we know that? Well, that's because sulfuric acid is a diprotic acid. So let's begin by finding the concentration of this sodium hydroxide solution. And for this one, I know I told you that I don't really like to use that formula for CaVa divided by CbVb equals Na over Nb. But in this case, we are going to use that formula. You can still use the stoichiometric calculations. They're going to work perfectly well. But I'm just going to use that because it's the quickest. We'll use the stoichiometric calculations in more complex calculations, such as finding the pH in the next problem. Okay. So here they told us the mass of sodium hydroxide as well as the volume. So we can easily say the concentration of sodium hydroxide is defined as the number of moles divided by the volume. Now, how many moles do we have? We don't really know the number of moles, but we can calculate them. But we don't need to use this formula, really. We can just use the one that says mass divided by the molar mass times the volume. Because anyway, we know that mass over molar mass is the number of moles, so we didn't change anything. The mass is given to us here as 4 grams. And what about the molar mass? Well, we can quickly calculate it aside. The molar mass of sodium from the periodic table, that is 23. The molar mass of oxygen is 16. Hydrogen, it is 1. So the molar mass of sodium hydroxide will be 40 grams per mole. The volume is given to us in cubic centimeters, so we need to convert it to cubic decimeters by dividing with 1,000. And when we do, we get 0.5. So when we say 4 divided by 40 times 0.5, we find that the concentration is simply 0.2 mole per cubic decimeter. So this was question number 1. Well, that's perfectly fine. Now, the next question is asking us to find the pH, but the pH of the sulfuric acid solution. So now that we know the concentration of the base, and we also know the volume of the base, it's 12.5 cubic centimeters. We also know the volume of the acid. Then it's very easy for us to find the concentration of the acid using the formula that I said I don't really like to use. But in this case, it is the easiest in business. So let's go ahead and do that. So we tell them that the concentration of the acid times the volume of the acid divided by the concentration of the base times the volume of the base is equal to the number of moles of the acid divided by the number of moles of the base. And remember, this one comes from the balanced chemical equation. It's the mole ratio. Okay? Well then, the concentration of the acid is what we are looking for. And the volume of the acid is 12.5 cubic centimeters. But for this formula, we know that we don't need to convert this to cubic decimeters. We can just leave it in cubic centimeters. And the concentration of the base is the one we calculated previously. That is 0.2. The volume of the base is 25 cubic centimeters. Do you see that? This volume is in centimeter cubed. This one is in centimeter cubed. So they will simply cancel each other out. So from the balanced chemical reaction, we can see that the coefficient of sulfuric acid is 1. And the coefficient of sodium hydroxide, that's going to give us a 2. Then how do you make this concentration of the acid the subject of the formula? Well, that's easy. You just need to cross multiply. And now on your left-hand side, you'll be having 2 times 12.5, which will be 25 times Ca. On your right-hand side, you'll be having 0.2 times that, but you'll still have to divide by 25. So I know you know how to make something the subject of the formula, so I'm not going to bore you with that. I'll just do it into my calculator. So when I go to my calculator and I say 0.2 times 25, and I say this entire thing is further divided by 2 times 12.5, well, I find that the concentration of the acid will just be how much? It seems like I made a little bit of a mistake here. Did I? Let's see. Oh, this 12.5 is actually the volume of the base, and the 25 is the volume of the acid. Sorry about that. Because I was getting things that are equal to each other, which is not always wrong though, but for this case, it was a little bit suspicious considering the mole ratio. Well, not entirely, but nevertheless. Yes, this one is 12.5. So I'm supposed to have 2 times 25 in my denominator. And in my numerator, I'm supposed to have 0.2 times 12.5. And when I do, I find that the concentration of the acid will just be 0.05 mole per cubic decimeter. But now we know that sulfuric acid is a diprotic acid, which means that the concentration of the hydronium ions will be twice as much the concentration of the acid. Because of that reason. So we are going to have twice as much 0.05. And when we times this by 2, we get 0.1 mole per cubic decimeter. Okay, so now we know the concentration of the hydronium ions. Then it's very easy to find the pH of the solution, because we know that the pH is the negative logarithm of the concentration of the hydronium ions. So we have the negative log of this, which if you press into your calculator, you get exactly 1. So this is the pH of the solution. You could have used the stoichiometric calculations, it's perfectly fine. But this formula was the easiest in business because we were dealing with a simple situation. Here the question was only asking for the pH of the acid, not the pH of the final solution. Very important to know the difference between those two. In the next example, we'll be looking at the pH of the solution, the final solution, and you'll get to see the difference between